Hello everyone and very good evening. I hope आप लोग अच्छे हो and you people are reading solving questions. But just a moment ago I asked with everybody how many of you did the homework. None of you replied. I mean, just let me know how many of you forgot it, how many of you tried it, how many of you I mean you knew about this homework thing, but I mean intentionally you couldn't or you didn't. Intentionally you didn't. Yeah. How many of you went this ways? Anybody who tried it? Anybody who forgot it? Anybody who didn't just bother to do it? Come forward. देखो अभी तक मैंने I mean whatever work I gave to you, you didn't do it. Network issue. Am I not audible? Okay, let me have a status check. So let me know if I'm audible or not. Am I audible, visible? Okay. Okay. Maybe he's talking about he was not there in the class yesterday, maybe. Okay, for one person, there was network issue. ठीक है. Others, please, and please change your name to your original name. I mean, is this your name? Doesn't seem like. Anyone who did it? चलो ठीक है. ज्यादा परेशान नहीं करूंगी पूछकर. I will move ahead with explanation because me being a teacher, it's my duty, and also I feel like I'm obliged to let you understand what in anything. I mean, let you understand all the concepts of capacitor or any chapter. But when I give you homework, there is some intention hidden behind it. And that intention for this question was plainly, I wanted you to figure out how things could be done. And if you're sitting with certain number of questions, you yourself is trying to figure it out how it can be done. That will definitely add to your question solving ability. So that's very much required. I mean, if you're not doing it, you are certainly losing a lot. मैं हर दिन यही लेक्चर देती हूँ. सो टुडे आई विल कट इट शॉर्ट हियर. Let's not discuss more on this thing, how much it is important for you to solve the question. Let's not discuss that anymore. And next time I will be giving you homework, I won't be asking you because you people don't do it. I'm just wasting my energy in vain. There's no purpose of asking it. Even if you've not done it, you can come out with things like, okay, I couldn't do because of this reason. I couldn't remember it. I mean, anything you can come out with, but simply you people don't give it a sit. I would say, चलो ठीक है, कोई नहीं. Ultimately, your concepts will betray you. I'm telling you. Because after 1 year, you will be sitting in the examination hall. And then if 2 months back before, you will be dreaming like getting some 20, I mean, good marks, good rank. It doesn't come this way. I mean, you cannot simply pluck dreams. It's nowhere just blooming and you can go and pluck it. No, that going process is really a process of work, determination, continuity. Done hai? So that you need to do. Distribution of charge on plates. So what happens when we in the yesterday's class, I told you what we do is there are two plates given here. On one plate, we are giving Q1 charge. On another plate, we are giving Q2 charge. If we talk about any plate, then each plate has two surfaces. One is this surface, another is this one. So let's call this surface 1. Let's call this surface 2. Similarly, for this plate, let's call this surface 3 and let's call this surface 4. Now, this looks like plates of capacitor, right? Let's say second step kya tha? First step, you have to identify the number of surfaces. We have done it. Second step, to give a variable amount of charge to one surface. So let's say I'm saying this surface 1 has charge small q. So this is the variable charge that I am giving to the surface 1. यानी कि मुझे पता नहीं है q का value क्या है. I'm just assuming it is having charge small q. Then how much value this surface 2 will have? Because this whole plate has a charge of q1. Out of this q1, small q is going to the surface 1. How much charge will go to the surface 2? So that will be your q1 minus q. Over. Similarly, if now use the thing of capacitor, in capacitor we know facing surfaces have equal and opposite charges. So if I say this surface has a charge q, then you will say this surface has a charge minus q. So here to the surface 3, from whatever we have done in capacitor, we will say this surface has a charge minus q, and this fourth surface has a charge of q2 plus q. Because adding charge on surface 3 and surface 4 should give you q2. And if you're going to add minus q and q2 plus q, you will be getting q2. So this is the correct distribution of charge. What is the distribution of charge we got? On this surface q, on this surface q1 minus q, and for this plate, this surface has a charge minus q, and this surface has a charge q2 plus q. So we have distributed charge. And if we know here the value of small q, if we know what is small q, we can easily calculate what will be the value of charge on all these 1, 2, 3, 4 surfaces. Okay? So I will just help you with this. Here has a charge q, here has a charge q1 minus q, this one has a charge minus q, and this one has a charge q2 plus q. Now what I said in yesterday's class was that take a point, take any point inside the conductor, because these two plates are conducting plates. So I'm taking here this point inside the conductor and try calculating electric field at point P because of 4 surfaces. This is surface 1, this is surface 2, this is surface 3, and this is surface 4. Now what will be the electric field at point P because of surface 1? With the direction. So surface 1 has what sort of charge? Surface 1 has a plus charge, like this. And point P is here, inside, somewhere here. So from here, electric field will come outward in this sense. Okay? And value of electric field at point P, because of charge on a seat, since this seat is again a very large seat, so we can assume here electric field, or we can write the formula sigma by 2 epsilon naught. I have told you, if there is charge distribution on the single surface, and for single surface, if you are writing electric field at any point P, any outside point, you can write it as sigma by 2 epsilon naught. And here sigma will be equal to what? This surface has a charge of a small q. Let's say it has the area of A. Okay? So these plates are like this. Look at this phone. So here you can see this is one surface, this is another surface. So this surface has certain area. So I'm saying this surface has area of A. So sigma will be equal to how much? Q by A here. Okay? So you will be writing Q by 2A epsilon naught. And direction is where? Direction is the distance. Over. Now let's write electric field because of surface 2 at point P. तो सरफेस 2 की अगर आप बात करो तो सरफेस 2 पे कैसे चार्ज है बताओ. सरफेस 2 हैज q1 माइनस q अमाउंट ऑफ चार्ज. तो सरफेस 2 को मैं यहाँ ड्रॉ कर रही हूँ. इट हैज हाउ मच पॉजिटिव चार्ज? q1 माइनस q at point P. For surface 2, point P is this side, है ना. For this surface, point P is this side. So here electric field will be in this direction. What will be the value? So again, sigma by 2 epsilon naught. Sigma for this surface will be q1 minus q by A, that is 2A epsilon naught. Direction is in which sense? In this sense. Now let's write the electric field at point P because of surface 3. Okay? So on surface 3 looks like what? If this is surface 3, here it has negative charge. How much? Minus q. And for this surface 3, point P is this side, right? Here somewhere. So point P is here. Here electric field will be in this direction because it has a negative charge. Value will be what? Sigma by 2 epsilon naught. Sigma is q by A. So q by 2A epsilon naught. if somebody is getting confused regarding कि मैंने यहाँ q को minus q क्यों नहीं लिखा, so minus q is the sign of charge and sign of charge is getting taken care of by the direction of electric field. So when you are writing the magnitude, you just need to write the magnitude. Done it? And here direction is this. So this direction is taking care of what is the nature of charge, positive or negative. ठीक है? Now let's write electric field at position P because of surface 4. That is the final surface, right? So this is surface 4 and how much charge it has? Q2 plus Q. This is the positive charge, right? And for this point P is somewhere here. So electric field will be in this direction. Done it? But what will be the value? Q2 plus Q by 2A epsilon naught. And what is the direction? Direction is in this one. अब देखो मैंने कल क्या बताया था कि since point P is inside the conductor, at point P electric field is 0. So what you will do here, you will do one thing, E1P plus E2P plus E3P plus E4P will be equal to 0. Okay? So you see here, two electric fields are in the right direction. Which two? These two. So let's add these two together. So if you will add these two together, what you are going to get? You are going to get Q1 minus Q by 2A epsilon naught plus right hand side को मैंने एक साथ जोड़ रही हूँ मैं, ठीक है? And this is equal to Q by 2A epsilon naught plus Q by 2A epsilon. So this total electric field is in the right direction. How much electric field will be in the left direction? You will add this one and this one. So I mean E1P and E4P. So that is Q by 2A epsilon naught plus Q2 plus Q by 2A epsilon naught. This is in this direction. And electric field of right direction should be equal to electric field of left direction because net electric field is what? 0. So here what I'm going to do is I'm going to equate these two, sum of these two electric fields. Okay? So I will do this. Now just you need to solve. 2A epsilon naught is common everywhere, cut it. And here you will get Q1 minus Q plus Q is equal to Q plus Q2 plus Q. Okay? So if you see here, this thing will get cancelled. 2Q is equal to how much? Q1 minus Q2. So Q will be equal to how much? Q1 minus Q2 by 2. So this is the value of Q. Now, if you know the value of a small q, you can write what is the value of Q1 minus small q and so on. So you can clearly now distribute charges on all the surfaces. So this was surface 1, this was surface 2. 1 पे कितना charge गया? Q1 minus Q2 by 2. What will be the charge on 2? That is your Q1 minus Q2 by 2. And that is equal to how much? So this is Q1 plus Q2 by 2. Done it? This will be the amount of charge on surface 2. This is 1, this is 2. If you talk about surface 3 and 4, surface 3 has minus q charge. So that is minus of Q1 minus Q2 by 2. And what is this charge on the fourth surface? So if you talk about fourth surface, charge is your Q plus Q2. So Q is going to be how much? Okay, this is Q plus Q2. So this is equal to Q2 plus Q1 minus Q2 by 2. So this is equal to Q1 plus Q2 by 2. ठीक है? So this is how we distribute charges. अब तुम लोग सोच रहे होगे कि मैम ने ये क्यों करवाया? मैंने इसलिए करवाया क्योंकि at so many places you might get questions like on one plate charge is given, on other surfaces, I mean on the whole plate charge is given. On surrounding surfaces, you are asked what will be the value of charge. So you should know the method, how you can go around it. Okay? Chalo. This is your homework. Again, it's your will. If you want to do, if you want to practice, you should. If you want yourself to be benefited, you will. Otherwise, if you don't bother about doing question, it's fine. It's totally okay because ultimately it's your business, right? Done है? तो करना होगा कर लेना, नहीं करना है मत करना. It's your call. I mean, you're not a child, yaar. You're not somebody who is reading in nursery or LKG or UKG. That I need to tell you the ethics of continuity and ethics of work and ethics of following lectures and classes. No, you don't require it. I mean, you're enough grown up at this stage of your life. You understand what is good and bad for you. है ना? At least this much you understand. It's fine. तो मैं बॉदर नहीं करने वाली इतना किसी को भी. You do this question now. Again, इस question से we will get to learn a lot of things. So this is going to be an interesting question. Do everybody and let me know. Take your time, ठीक है? थोड़ा सोचो और क्वेश्चन पढ़ो, कुछ सोचो, क्या पता कुछ समझ में आए. नहीं भी आए तो इट्स फाइन, बट यू नीड टू थिंक अराउंड इट. तो थिंक अराउंड इट. Lakshmi is not present today in the class. Where is she? Anybody can update me? किरण, सभी लोग होमवर्क मांग रहे हैं. अच्छा ठीक है, दिखा देती हूँ. ये है होमवर्क स्लाइड. ठीक है, करोगे तो तुम फायदे में रहोगे. मुझे क्या है, मुझे तो सैलरी मिल ही जाएगी ना. तुम होमवर्क करो या ना करो, मुझे तो पैसे मिल जाएंगे. क्या ही बोलूं मैं. नुकसान तो तुम्हारा है. देखो, गोल तुम्हारा जो भी हो फिक्स कर लो, और फिक्स करके सोचो कि उस गोल के लिए काम कितना करना है. डोंट डिसीव योरसेल्फ. मैं ये कहती हूँ, कभी कभी क्या होता है ना, हम सपने बड़े बड़े देख लेते हैं. बड़े सपने कब होते हैं, सपने बड़े कब हो जाते हैं पता है? व्हेन वी वर्क, व्हेन वी डू नो वर्क, व्हेन वी आर नॉट इन्वेस्टिंग एनी सॉर्ट ऑफ एनर्जी इनटू दैट, तो सपने बड़े होते हैं. ठीक है. नथिंग इज बिगर if you are really at it, if you are really doing. डन है. तो ऐसा नहीं कि तुम सपने बड़ा देख लिए. बड़ा मतलब अगेन, इफ यू हैव ड्रीम्ड ऑफ समथिंग बट यू आर नॉट वर्किंग टुवर्ड्स इट, देन यू फुलिश पर्सन. ठीक है. कुछ लोग सोए सोए बड़े अच्छे अच्छे ख्वाब देखते हैं. अच्छी चीज है, अच्छा लगता है ना. बट इट्स नॉट समथिंग दैट इज रियली गोइंग टू मेक यू फील गुड इन लॉन्ग रन. दैट इज fleeting happiness, fleeting pleasure. It really feels good to, I mean, close your eyes, just have an imagination, something that you really want to experience in your life. Just think about it, weave stories around it. It feels beautiful. It feels like, I mean, you're really in some pleasant environment. But that's fleeting happiness. So जो भी तुम्हारे सपने हैं ना, make a plan, work around it. ठीक है, चलो. चलो, मे बी अभी तुम लोग बहुत नए हो इस क्वेश्चन के लिए, और मैंने अच्छा क्वेश्चन ऐड किया है. सो आई विल एक्सप्लेन इट. ठीक है, कैसे इस क्वेश्चन को हम सॉल्व कर सकते हैं. एंड इफ यू वांट टू डू मोर ऑफ सच क्वेश्चंस, अगेन गो टू एच सी वर्मा. एच सी वर्मा का बुक खोलो, वहां पे बड़े अच्छे अच्छे क्वेश्चंस है. सारे कॉन्सेप्ट पे अच्छे अच्छे क्वेश्चंस होते हैं. सो यू शुड ओपन दिस बुक. दिस एक्चुअली हैज गुड कलेक्शन. ठीक है. अब देखो, इस क्वेश्चन में है क्या, ये सब दिख रहा है ना अजीब अजीब सा, 1 2 3 4 5, है ना. सो व्हाट इज दिस, दिस आर प्लेट्स बेसिकली, आइडेंटिकल कैपेसिटर प्लेट्स. सो प्लेट 1 is like this. It will have two surface. Similarly, plate 2, plate 3, plate 4, plate 5. अब देखो, बैटरी से कनेक्टेड है ये. ठीक है, हमने पढ़ा भी है ना, कैपेसिटर को हम किससे कनेक्ट करते थे, बैटरी से. चार्ज डिस्ट्रीब्यूट होता था, एक से ज्यादा कैपेसिटर है, देन वी ट्राई टू सी इफ देयर इन पैरेलल और सीरीज. वी हैव डन सच सॉर्ट ऑफ थिंग, राइट? सो हियर आल्सो व्हाट वी आर डूइंग, we are connecting this system of plates, these two plates, with the negative terminal of the battery. Let's say this negative terminal of battery has potential of V minus, and this positive terminal of the battery has potential of V plus. Now start dividing the potential, or start marking points on the circuit in terms of potential. So if this point is V minus, this point will also be V minus, and hence this point also V minus, and this point also V minus. So you can see here plate 2 and plate 4. अब यहाँ पे मैं categorically लिखती हूँ, plate 2 and plate 4, they will share the same potential, that is V plus. ठीक है. And what will be the, now let's talk about V plus. So this point also will have V plus, because in between these two things, in between these 2 points, there are no electrical devices, so no potential, right? Here also potential will be same as V plus. Now, if you look at it, this point, from this point, this is going out, so this point also has potential V plus, this has also V plus, and this point also has potential V plus. You can see clearly. पोटेंशियल कब सेम होता है? जब दो पॉइंट के बीच में कोई इलेक्ट्रिकल डिवाइस नहीं आता, ओनली कंडक्टर इज देयर दैट इज कंडक्टिंग वायर. So these 3 points will have same potential V plus. Now, if you talk about which plate, plate 1, plate 3, and plate 5, they share the same potential V minus. So if somebody here asks you about what is the equivalent capacitance, कैसे निकालोगे? कौन सीरीज में है, कौन पैरेलल में है? By looking at it, simply by looking at the diagram, we cannot reach to this conclusion, right? We cannot, because it's not visible. It's not visible correctly, clearly, right? So let's do one thing. देखो यहाँ पे पोटेंशियल के टर्म में कितने पॉइंट्स हैं? दो ही हैं, क्योंकि आइदर पोटेंशियल V प्लस है या पोटेंशियल V माइनस है. So in terms of potential, we have only 2 points. Done it? So randomly you do one thing. You write here 2 points, point A and point B. So let's say this point is point A and this point is point B. So point A has what potential? V minus. Point B has what potential? V plus. Now, in between these 2 points, there are capacitors connected. जैसे अब देखो, अब मैं कैपेसिटर को दिखाऊंगी कहाँ कहाँ कैपेसिटर है. So these two plates are forming one capacitor. I mean, plate 1 का ये वाला surface, and plate 2 का ये वाला surface. These two surface together will form one capacitor. और देखो प्लेट 1 कहाँ से निकल रहा है? V प्लस से. सो V प्लस से आप एक प्लेट निकालो एंड V माइनस से भी एक प्लेट निकालो. दिस विल फॉर्म वन कैपेसिटर, दैट इज दिस वन. ठीक है? सो लेट्स से दिस इज C1. डन है? सो यहां मैंने बना दिया C1. उसके बाद क्या दिख रहा है तुम्हें? उसके बाद और कैपेसिटर दिख रहे हैं मुझे. दिस इज ऑल्सो फॉर्मिंग अ कैपेसिटर. प्लेट 2 का राइट सरफेस, प्लेट 3 का लेफ्ट सरफेस. अगेन one plate is having potential V plus, another V minus. So V plus से एक प्लेट निकालो और V minus से दूसरा. It's like this. ठीक है? Again you will come here. Again there is one more capacitor. This is getting formed by right surface of plate 3 and left surface of plate 4. And one plate has a potential of V plus, another V minus. तो फिर से एक काम करो, V minus से एक प्लेट ले लो और V plus का एक प्लेट ले लो. ले लिया हमने, 3 लिया अभी तक. ठीक है? Now what else we can see? There is one more capacitor here getting formed by right surface of 4 and left surface of 5. Here also you can see there one plate is having potential of how much? One plate is having potential of V plus, another V minus. मैं इसको और छोटा बना रही थी so that accommodate कर सकूं. So here again one more plate. So how many capacitors we are getting? We are getting 4 capacitors. ठीक है? And what is the potential difference between these 4 capacitors? V plus minus V minus. यही है ना potential difference? So all these 4 capacitors are in what? Are they in series or parallel? क्या होगा बताओ? Are they in series or parallel? What do you say?
Parallel.
Parallel? Yes. Any other? Anyone else? They are in parallel, right? So how we will calculate C equivalent? So C equivalent will be C1 plus C2 plus C3 plus C4. And what is the value of C1, C2, C3, C4? Yes, Sanjana, correct. And yes, Kiran, correct. So सारे ही प्लेट का एरिया सेम है, सारे ही प्लेट के बीच का सेपरेशन D है. So every capacitance is equal to epsilon naught A by D. So C1 is equal to C, C2 is equal to C, C3 is equal to C, C4 is equal to C. So this is equal to 4C. Done it? तो इक्विवेलेंट कैपेसिटेंस अगर आपसे कोई पूछता है ना, तो C equivalent is 4 epsilon naught A by D. This is C equivalent. Done it? Any doubt, anyone so far? If yes, you can let me know. Okay.
4C, how will you write?
Kiran. Okay, 4C, how I wrote, like here you are having four capacitors, they are in parallel. When capacitors are in parallel, we add them like in series. So I'm calculating C equivalent. That is, I'm trying to replace these four capacitors with single capacitor. So you will write C equivalent, and that will be here C1 plus C2 plus C3 plus C4. And C1 is equal to C, C2 is also equal to C, C3 is also equal to C, C4 is also equal to C. So C equivalent is 4C. ठीक है? Yes. Is it clear?
Yes, ma'am.
Okay. Okay. If any other doubt is there, you can write to me also. I mean, you should get clear of कि कैसे कैसे आया है. And again मैं बोलूंगी, तुम लोग हर क्लास के बाद class will feel more difficult if you will not practice questions. So I highly recommend you people practicing questions. Me doing it is one thing. You doing it is so much thing. So yeah, that's very important. Now here question was what? Charge on plate 1 is how much? And on the plate 4 is how much? So here potential difference is given V. So V plus minus V minus is given as equal to V. And we are asked what will be the charges on these four plates. So if you see here, again मैं यहाँ पे बोलूं, जैसे देखो ये हमारे पास फोर कैपेसिटर्स मिले ना, ऐसे ऐसे मिले. सो वी आर हैविंग फोर कैपेसिटर्स. डन है. और ये है तुम्हारा बैटरी. क्वेश्चन को ऐसे रिड्यूस कर सकते हैं ना, दिस इज बैटरी हैविंग पोटेंशियल V. Let's say from here Q amount of charge is going out, or let's say 4Q amount of charge is going out. Why I have taken 4Q? क्योंकि यहाँ पे जाके चार्ज फोर पार्ट्स में डिवाइड होगा. So I have taken 4Q simply. So all capacitors are having same capacitance. So at this junction, this 4Q charge will get divided into four equal parts because all these are having same capacity. So same charge they will draw. Okay? So it will have plus Q, it will have minus Q, it will have plus Q, it will have minus Q. This one plus Q, this one minus Q, this one plus Q, this one minus Q. Now let's distribute it here in the question. Because this distribution will be, I mean, we really need to tell कि कौन से plate पे charge किया है. So plate पे charge and capacitor पे charge are two different things. क्योंकि प्लेट 3 को ध्यान से देखो, प्लेट 3 is contributing in the formation of two capacitor. ठीक है. So we cannot say कि सारे प्लेट पे Q charge है. Done है. And here I have taken 4Q, and here 4Q will be equal to how much? It will be equal to C equivalent into B. ठीक है. So C equivalent is how much? That is your 4C into V. So this is 4Q. Q is equal to how much? CV. C is how much? Epsilon naught A by D into P. So Q value we know. Now we need to distribute charges on all these plates. So इसको चलो carefully करते हैं. फिर से explain करती हूँ मैं कैसे कर सकते हैं. हमने कितना चार्ज निकाला था बैटरी से? लेट्स डील विद द ओरिजिनल डायग्राम. यहां से हमने चार्ज निकाला 4Q. यहां से कितने चार्ज निकले होंगे? सेम नेगेटिव चार्ज माइनस 4Q. नाउ लेट्स टॉक अबाउट 4Q. एट दिस पॉइंट 4Q, we have how many ways to go? Three ways we can, three branches are there in which charges can go. Now, if you talk about plate 5, it contributed in the formation of only one capacitor. If you talk about plate 1, it also contributed in the formation of only one capacitor. If you talk about plate 3, it contributed into the formation of two capacitors. So this way, if Q charge is going, this way Q charge, then this way 2Q amount of charge will go, such that all will add up to 4Q. So what will happen with the 2Q? Plus Q will be on this surface and plus Q will be on this surface. So if somebody asks you how much charge is there on plate 3, you will say, I mean, Q का value हमारा कितना आया? Epsilon naught A by D into B. So on plate 3, there are 2Q value of charge, 2 epsilon naught A by D into B. On plate 1, epsilon naught A by D into V, because that is taking just Q charge. Now, if you talk about this minus 4Q charge, अब आप देखो इसके पास दो रास्ते हैं. This plate 2 is contributing in the formation of two capacitor. इधर minus 2Q आएगा, and similarly here minus 2Q. So this surface will have minus Q charge, and this surface minus Q. Similarly, this surface will have minus Q charge, and this surface minus Q. ठीक है. सो प्लेट 1 पे कितना चार्ज है? Q. प्लेट 4 पे कितना चार्ज है? आप देखो minus 2Q. It has a charge of minus 2Q. It has a charge of. So this question came in JEE Advanced 1984. Why I included this question? Just to make you understand in a better way the concept, how we can distribute charges carefully. ठीक है. So this is one of the best question that we can do in capacitor. If you have understood it, it's better, it's good, but it doesn't mean by understanding simply this question you will be able to do all the questions. For that you need to do practice. So practice is key to physics. Anyone has doubt in this question, then let me know. This is very, very important. If you do it, you will get it. Whatever, whichever college you are desiring to get, I mean, you will get to there. Where is Lakshmi? Can anyone let me know if some of you or maybe some students sitting here, maybe from her school. I don't know from which school she is. Chalo, take care. No doubt. If not, then it's good. Let's do this question. This we have already done it, right? So it's already done. Okay. This question we wanted to do. Is question ko karo. What is the question? Find out charge on each capacitor. You have to, but this question you won't be able to do without KVL. And KVL so far we have not learned. We will learn that in capacitor. Okay, Jinvi Chitra Durga in Karnataka. Okay, so where is he? Last question slide. Okay, Thanush, I will show you. ये वाला. Priya, you are also from the same school, right? Great.
Okay, ma'am.
हो गया? चलो ठीक है. Thank you. Kiran, okay. ठीक है. Inform her once. If you people are in hostel in this school, then please tell her what questions happened and help her to get things. If you people are at home, then you can call her and tell her. ठीक है. एक बार उसको बता देना. It's important. ठीक है. चलो ये क्वेश्चन मैं अभी इसलिए नहीं करवा रही. We will get back to such questions when we will be done with KVL reading. KVL we will read in current electricity. ठीक है. So इसको बाद में करेंगे. Now this is the last leg of capacitor that we need to learn, and this is your dielectric and effect of dielectric on capacitor. This is very, very important portion of capacitor. Remember, यहाँ से क्वेश्चंस बहुत आते हैं. क्वेश्चन तुम्हारा आइदर सिंपल और कॉम्प्लेक्स सर्किट से होगा, कैपेसिटर सर्किट, और क्वेश्चन विल बी फ्रॉम कैपेसिटर हैविंग डायलेक्ट्रिक. ओके, सो वी विल डील विद दैट. व्हाट इज डायलेक्ट्रिक? आप सभी जानते हो व्हाट इज डायलेक्ट्रिक. डायलेक्ट्रिक इज बेसिकली योर इंसुलेटर. दिस इज व्हाट? दिस इज इंसुलेटर, नथिंग एल्स. दिस इज निक नेम ऑफ इंसुलेटर. अब देखो डायलेक्ट्रिक कितने तरह के हो सकते हैं. डायलेक्ट्रिक कैन बी पोलर, डायलेक्ट्रिक कैन बी नॉन पोलर. You understand, I feel like, what is the meaning of polar. Chemistry के students हो तुम लोग, so you know polar means if there are some polar molecule, जैसे तुम लोग पढ़ते हो Cl2. This is not polar molecule. Why? Because one atom is of Cl, another atom is also identical. Electronegativity of both the atom is same, and that is why during the formation of covalent bond, not any electron is more get attracted towards another. I mean, there is no attraction sort of thing happening here because electronegativity is same. And that is why we say this chlorine will get not excess negative or positive charge, and also this won't get any excess negative or positive charge. But you talk about, let's talk about water. Water आपने पढ़ा है ना? Water का structure कैसा होता है? This is oxygen, this is hydrogen, and this is hydrogen, right? Now there is huge electronegativity difference between hydrogen and Insulator का मतलब, okay, insulator means something that doesn't conduct electricity. Everyone knows insulator. Insulator का मतलब non-conductor. Okay, sorry. I taken for granted कि you must be understanding this. Sorry. This is non-conductor. Something that doesn't conduct electricity.
Madam, example.
Example, there's so many. जैसे तुम प्लास्टिक ले लो. जैसे हम when you taste current in the board, what do you use? You use that, what is that called? I mean, whatever instrument you are using that has a plastic capping. Why plastic capping is there? Because plastic doesn't conduct electricity and hence you won't get any shock. Okay? So insulator is basically non-conductor, something that doesn't conduct electricity. And why it doesn't conduct electricity? Because it has no free charges, free mobile charges. Mobile means movable charges. Okay? So this is your insulator. Then जैसे heat के case में भी insulating things we use. When you use a pan का जो handle होता है, that won't be made of steel or something, because if that is made of steel, when you are just stirring your food or something, food is hot, your handle will also get hot, and in that case you will quite feel uncomfortable in the kitchen cooking, right? So I mean, insulator is something that doesn't conduct, yes, that's made of brass, so it will conduct electricity, it will conduct heat, it will conduct. I mean, brass का cookwares भी होते हैं, kitchenettes होते हैं brass का, and that's actually conductor of heat, that will conduct. It's not insulator, is it? It is not, क्योंकि brass का आपने सुना है ना, वो pans होते हैं. Brass is suggested to be used in kitchens because it's good for our health and all. So, I mean, brass, I'm getting, that is in Hindi called pital. I don't know if, let me check. That is an alloy, is, brass is not an insulator. Okay, it's not. Done it. So polar or non insulator, you have understood what is it. Now insulator is of two kind, polar and non-polar. What is the meaning of polar and non-polar? मैंने एक example दिया Cl2 का. So Cl2 की अगर आप बात करो, then this Cl is not having any extra positive or negative charges on it, and this is neutral, and this is Cl2 bond. So this is non-polar. Now if you talk about H2O. O is more electronegative than hydrogen. OH bond is made by one electron of hydrogen and another electron of oxygen. So this electron of oxygen and this electron of hydrogen. Let's talk about these two. This electron of hydrogen will get more attracted towards the oxygen. So somewhat hydrogen will lose a certain amount of charge to the oxygen, you can say. So it will get plus delta charge and it will get minus delta charge. So on hydrogen, there is certain value of charge there, though it is very small. And on oxygen also there is negative charge, very small, very, very small. Similarly, because of this OH bond also there is negative, there is positive. ठीक है. In electrostat, I have told you, dipole का direction negative से positive होता है, but in chemistry we take it opposite way, from positive to negative. ठीक है. Alloy, as a alloy is what? Alloy is made of one or two materials, right? So some alloy may be insulator, some alloy may be conductor. ठीक है. Depends on what materials you are putting in to make that. Kiran? Sorry, Varma, not Kiran, sorry. ठीक है. सो व्हाट विल हैपन ओवर हियर, यहाँ पे आप देख सकते हो, यहाँ पे फिजिक्स के टर्म में अगर मैं बताऊं तो डाइपोल का डायरेक्शन यहाँ पे ऐसे है एंड हियर डाइपोल डायरेक्शन इज हियर. सो इफ यू टॉक अबाउट H2O molecule, it has dipoles, so it is polar, it has poles of positive and negative charge, it is polar. So polar molecule, The molecule which are having dipoles inherently, non-polar which has no dipoles inherently, because if you talk here about Cl, no delta plus or delta minus sign on anything, because दोनों एक ही nature के हैं. Done? So it won't happen here. So this is polar and non-polar. So polar will look like what? Polar will look like, just say if you talk about this is one H2O molecule, it has certain dipole, right? I told you one dipole is in this direction, another, let's say this is P, this also will be P. Net dipole will be in this direction. So each H2O molecule has certain value of dipole. So polar molecule will look like each molecule will have certain dipoles. And when you are having polar insulator, let's say this is polar insulator, okay? Insulator kept in your hand. Suppose you are holding one polar insulator in your hand. What you can talk about these dipoles orientations. So in hand, if you are holding it, means you are keeping it at normal room temperature. So room temperature की अगर बात करो, you talk about you are talking about 298 Kelvin, and you have studied in what? In thermodynamics, in KTZ, kinetic theory of gases. I don't know how many of you were really regular to classes, because I have dealt with it in detail. I have taught each and every things and each and every lines. So I have told you, if anything is at temperature greater than 0 Kelvin, it will have certain amount of kinetic energy. It will have energy. And because of that energy, each molecule will be moving randomly. And if molecules are moving randomly, their dipoles are randomly oriented, right? So that is why here, if you see, one dipole is like this, another is like this, another dipole this way, another dipole this way, and then this way. All dipoles are randomly oriented. So at room temperature, they will be randomly oriented. Okay? This is one thing. Another. Non-polar dipoles. For non-polar dipoles, there is no inherently dipole value present. कह सकते हो कि उसका positive और negative charge are at the same point. That is, there is no separation of charge there, and hence no dipole. So non-polar dipoles को, if you want to, non-polar insulators को, dielectric को, if you want to represent pictorially, you can represent it like this, where you will show positive and negative charge at the same place. And in case of polar, you will show negative and positive charge separated by separation, and hence they have dipole. Okay? So this is this. Now what we are going to do is, electrostat में मैंने तुम लोगों को बताया what will happen if we put conductor in the external electric field. Now what we are going to do, we are going to put polar dielectric first. So we are going to put polar dielectric into electric field. What will happen? What do you think will happen? Okay? How dipoles behave with electric field? Question is this. बताओ dipoles कैसे behave करता है electric field में? I have taught each and everything in, again, electrostats. I have told you everything in the nature wants to be stable. Just have this in your mind. इससे बहुत सारे क्वेश्चन सॉल्व होते हैं certain region. Everything in nature wants to be stable, है ना? So सब कुछ stable होना चाहता है. अगर उसको चांस मिले तो वो स्टेबल होगा. If something is getting an opportunity, they will try to become stable. And a stable means what? Less potential energy. And if I'm talking about potential energy, then you should think of potential energy of dipole in the electric field. So what is the formula of potential energy of dipole? Minus P dot E. And for stability, if you remember, I discussed two cases, unstable and stable equilibrium. We got a stable equilibrium for the case of theta equal to 0 degree. And in that case, potential energy will be minimum minus P. We have dealt with it already, right? We have done it. So at theta equal to 0, why? Because at theta equal to 0, energy is the minimum. Theta is what? Angle between dipole and electric field. So in this case, when dipole is randomly oriented, once it will face electric field, once it will feel electric field in its region, it will try to become stable. So it will try to orient itself into the direction of electric field. So सारे dipoles कौन से direction में orient होने लगेंगे? In the direction of electric field. जब electric field नहीं था, then because of temperature it is random. Done. And because of the presence of electric field, what will happen? This randomness will start varying the dress of discipline. I mean, they will just try to get into one single direction. And that direction will be what? In the direction of electric field. So let's talk about it now. So what will happen if you are putting external field here? Dipole will get oriented in the direction of dipole. Why? To get stable. Why stable? Anything in nature wants to be stable. तुम लोग career stable चाहते हो. You want your bank balance to be stable. You want a stable family and everything. Everyone is running towards stability. No wonder there is so much chaos and entropy in our environment, but still, this is sarcasm. I mean, everyone is just running towards stability and more peace, but still entropy of the nature is increasing day by day. So, I mean, these are just the opposite things happening. So here, what will happen in the presence of external electric field? Dipoles will orient itself in the direction of electric field. This is going to be the scene. अब इससे क्या होगा बताओ? अब सारा गेम यही है. गेम ये है कि सिंस मैंने यहाँ पे डाइपोल, I have shown you, I mean, one dipole is here, another is here, but there are millions of dipoles, billions of dipoles, because in a single piece of certain material, certain dielectric, there's so many atoms present, and hence so many dipoles. So एक का positive दूसरे के negative को touch करेगा, because those atoms are quite closely packed, right? So one plus will touch another negative. This plus will also touch adjacent negative. Here also the same thing will occur. And here also same thing will occur with this, same thing will occur with this, and here also the same thing. But if you talk about the surface wala charge, so here negative has nothing in its vicinity, no positive in its vicinity, because this atom is the surface atom. ये किस atom का dipole है? Surface atom का dipole है. And similarly here. So in the middle, or positive negative will get cancelled, and on the surface, in the direction of electric field, here we will get negative charge, and here we will get positive charge. So overall, certain value of electric field will get generated inside the dielectric. But remember, in case of conductor also, internal electric field was getting generated. In that case, because of force acting on the mobile charges, and in this case, because of dipoles getting aligned in the direction of electric field. In the case of conductor, there's so many mobile and free charges, and that is why their E induced can become equal to E external. But in the case of insulator, because of complexities of crystals and nature, what will happen? E induced will be less than E external. So here inside dielectric, electric field cannot be equal to 0. It cannot be equal to 0. Because of dipole or because of dielectric getting placed in external electric field E, electric field inside dielectric will become how much? E external minus E induced. Because E induced is opposite to the direction of E external, you can see. Done it? So तुम्हें समझ में ये आना चाहिए अभी तक कि when we put dielectric in external electric field, what happens? Inside electric field gets induced, and value of this is not equal to external. So net electric field won't be 0. It will be E external minus E induced. Later on, we will talk about its magnitude, how it is going to get affected. We will check that later, but let's talk about non-polar. Non-polar का क्या होगा when you are keeping non-polar in the dielectric? Sorry, in the electric field. So if non-polar dielectric is there, then what will happen? What is going to happen? अब देखो वहां यहाँ पे तो dipole है नहीं कि that will get aligned in the direction of electric field to become stable. Then stretching will happen here. यहाँ पे stretching होगा, खींचातानी जिसको हिंदी में कहते हैं. So some sort of stretching. Why stretching will occur? Because here you have supplied electric field. On the positive charge, force will act in the direction of electric field, and on the negative charge, force will act opposite to the direction of electric field. And because of this stretching, positive charge ka center, negative charge ka center will get separated by certain distance. And so dipole is getting generated, and all dipoles will stay aligned in the direction of electric field. So in case of polar dielectric, non-polar dielectric, what happens in external electric field? First, this electric field generate dipole, get it aligned in the direction of electric field, and same thing happens as it happened with the polar dielectric. So here देखो यहाँ पे electric field 0 था, their centers were same, Because of electric field not zero, stretching happened, center shifted, and hence dipole got generated. And if dipole is getting generated like this, all dipole will stay aligned in the direction of electric field. And if such thing is happening, then on this surface we will get negative charge, and on this surface we will get positive charge. Okay? So this is what will happen if you drop dielectric in what? In external electric field. In case of both polar and non-polar. So I hope you have understood. किसी को कोई conceptual problem है? Let me know. Anyone facing anything? Okay, Kiran. Anybody? किरण, वी विल यूज जैसे एप्लीकेशन ये होगा कि हमने कैपेसिटर पढ़ा ना, कैपेसिटर के बीच में क्या रखते हैं? कैपेसिटर के बीच में क्या रखते हैं? इंसुलेटर, ठीक है, यहाँ पे इंसुलेटर होता है हमेशा. सो नाउ वी विल ट्राई टू यूज इंसुलेटर, such kind of insulator which will increase the capacity of conductor. जैसे तुम ऐसे सीधा सोचो, कैपेसिटेंस का वैल्यू क्या था सिंगल पैरेलल प्लेट कैपेसिटर के लिए? एप्सिलॉन A by D. ठीक है. If there is vacuum in this space, then you say it is epsilon not A by D. If it is not vacuum, you say epsilon A by D. What is this epsilon? I have taught you in electrostat. Epsilon can be written as epsilon not epsilon R A by D. What is this epsilon R? Relative permittivity. And this relative permittivity is basically the properties of that media. That is also called dielectric constant. Epsilon R को मैंने कहीं लिखा था. This is dielectric constant. ठीक है. So I'm coming back to your question. इसको अगर epsilon R को later on we will indicate it by letter K, that is dielectric constant. So this will become K into epsilon naught A by D. So if in vacuum capacity is this much, in the presence of dielectric constant K, its capacity will become K times epsilon naught A by D. So certainly its capacity is increasing. Done it? So we are reading dielectric so that we can understand which dielectric we need to use in order to have or in order to achieve certain level of capacity of capacitor. Done it? So this is the role of dielectric. Clear है? What do you want to present? I'm declining this. Who is requesting to present something? क्या कर रहे हो तुम लोग? टाइम पास कर रहे हो? बोलो. This should not happen. Thank you. कौन कर रहा है ये? I will trace you. Don't do such things. Don't be a kid. You are a kid. We all are a kid. We all should remain. है ना? To let life flowing in our time. That's very important to stay a kid. But that doesn't mean you will be doing these activities. Thank you, Priya. Thank you. Still, it's not over. Is it over? No. 5 minutes. Okay. So I will just explain one thing. Polarization. That is basically a definition wala thing. So what is polarization? Polarization is dipole moment induced per unit volume. So we took a dielectric like this. This dielectric has certain volume. Let's say this. I mean. अगर तुम इसको ध्यान से देखो ना तो ये तुम्हारा क्यूबिकल है ना? क्यूबिकल मैंने बनाया नहीं है. बट इफ यू आर टेकिंग एनी कंटेनर और एनी पीस ऑफ डाइलेक्ट्रिक, it's like this. Because if you're taking anything in your hand, it will have certain length, breadth, and thickness. So let's say cubical dielectric you have taken. So this is like this. Let's say this is L, and this area of this thing is A. Let's say this is A. So on this plate of area A, negative charge has accumulated, and on this plate of again area A, positive charge has accumulated. है ना? इस पे negative charge है और इस पे positive. Let's say the value of this charge per unit area, that is charge density, is sigma p. So this will be minus sigma p, and this will be your plus sigma p. Okay? What is sigma p? This is charge induced by area. This is sigma p. Okay. So now you can see here there is a negative charge here and positive charge here, separated by distance how much? L. This distance is how much? L. So we can define dipole for this case. And what will be the dipole? Dipole को हम कैसे लिखते हैं? Dipole को हम लिखते हैं charge value into distance between those two. Charge value will be how much? If charge density is sigma p, then Q induced का value क्या होगा? Sigma p into A. So dipole will be sigma p into A into L. So polarization is what? Dipole moment induced. It is this per unit volume. Total volume is AL. If you will divide it, you will get this equal to sigma p. So what is the value of polarization? Value of polarization is, definition क्या है? Dipole moment induced per unit volume, and value is equal to induced charge density. This is what? This is your induced charge density. So कल के क्लास में what we will be doing, this much is done. ठीक है, कल का क्लास और भी इंटरेस्टिंग होगा, because we will see what happens if we drop dielectric in the space of capacitor, rather than keeping it vacuum or keeping it air like thing. We will be putting in between the space of capacitor dielectric. We may put more than one dielectric. थोड़े स्पेस में कुछ और डायलेक्ट्रिक डाल दिया. Maybe we will be using 4 dielectric. So here K1, here K2, here K3, here K4. We will see after adding dielectric how capacitance will change, how electric field will change, how energy will change, how potential difference will change, how force acting will change. All parameters we will read in the tomorrow's class. Okay, I will suggest each one of you to do as many questions as you can learn, because that is important if you want to and store all the concepts that you have learned. तुम्हें पता है, I mean, if you want to store something, you make container, and in physics thing, making container is doing practice. So if you want to store whatever you have learned in your classes, container will be your practice. So do practice question. अगेन मैं तब तक कहती रहूंगी जब तक तुम लोग करोगे नहीं. ठीक है, सो करना बहुत जरूरी है प्रैक्टिस, इसलिए मैं बार बार रिपीट करती हूँ. ओपन देखो, एक चीज और मैं तुम लोगों को बोल दूं, एनसीईआरटी बुक को ओपन करना. जो भी डायग्राम वाले क्वेश्चन है कैपेसिटर के, ऑल डायग्राम क्वेश्चंस, डू दोस क्वेश्चंस. ठीक है, ऑल्सो ओपन एससी वर्मा. कम से कम डायग्राम को तो कवर करो, ऑल डायग्राम क्वेश्चंस. ठीक है, प्लीज डू. If you don't have SC Verma book with yourself, do buy one if you can afford it. Please do buy. है ना, मोबाइल में डेटा डालने से अच्छा है you buy one book. That will be more helpful. And if you can't afford it, it's fine. It's normal. You can take the help of what? You can take the help of online thing. Priya, my name is Akshmala. Akshmala. Let me write my name. This is this. Because many people write it wrong way, so I've written Akshmal. ठीक है, okay. You all will be doing question. GN, what is this? I don't understand this Genji short form. So somebody has written something. Okay, library you have written. Okay, library is there, right? So yeah, in the Navodaya there is library, I know. So access the library यार, तुम लोग सभी लोग इशू करवा लो. Maybe there may be 40 students in your classroom. Not everyone can have it, but even if 10 books are there of HC Verma, even if 5 books are there, you people can rotate it. I mean, if there are 10 books, 5 books girls side should have and 5 books boys side should have, or depending on the population you divide it. And you just sit in group, do it, or whenever the book is free, ask with somebody, do it. That way you can do. ठीक है, so please everyone do it. कल मिलते हैं. ठीक है, कल के क्लास में मिलते हैं. किसी को डाउट है तो बता दो. इफ एनीवन हैज एनी डाउट, लेट मी नो. ओके, बाय बाय प्रिया, बाय, टेक केयर everyone, bye, take care, have fun. I mean, go for snacks, have your own time. And in the night time when you sit for remedial नहीं, night में क्या होता है? Night में there is one different name for that class. I mean, पता नहीं क्या बोलते, भूल रही हूँ मैं. Remedial timing is in the afternoon, right? Bye Kiran. Bye. Self study time. Yes. In that time you can sit and do the question. ठीक है? Evening study. Yes. Different names. Yeah. Evening study. Yeah, that is more common in Navodaya. Evening study. Yes, Sanjana. Correct. Okay. Night studies. Yes. Night studies भी बोलते हैं. सही कह रहे हो. चलो सभी लोग एंजॉय करो, ठीक है. मैं भी थोड़ा चाय कॉफी एंजॉय करती हूँ. बाय एवरीवन, टेक केयर. यू आर इन होम, सो एंजॉय द फूड. ठीक है. यस, एंजॉय इट. बाय बाय.